Tonight, this little recording is here to keep you company while you drift off to sleep. You don't have to remember anything, you don't have to follow every detail, and you definitely don't have to stay awake until the end. All you need to do is lie back, get comfortable, and let your thoughts slow down while the solar system quietly unfolds around you, one gentle story at a time. If you like, you can take a moment now to make your bed a little cozier. Adjust your pillow, loosen your shoulders, and let your jaw unclench. Feel the blanket resting softly over you, warm and reassuring, like a safe little atmosphere wrapped around your body. Let your eyes grow heavy as your breathing becomes smooth and easy, in and out, like a slow tide rolling across a quiet shore on Earth at night. In this calm space, we'll start right here at home, on our own planet, and then wander outward, farther and farther away from Earth. We'll visit our moon, the nearby rocky worlds, the giant planets and their moons, and then the icy edges of the solar system, where comets and distant worlds drift in silence. Each stop is just a soft, simple picture in your mind, a peaceful fact or two, nothing you need to hold on to, just gentle scenery passing by as you drift towards sleep. So, as you listen, you can let your awareness rest on the sound of the words more than their meaning. If your thoughts wander, that's perfectly fine. Imagine the whole solar system as a slow, glowing mobile hanging above your bed, planets and moons turning quietly in the dark. When you're ready, we'll begin our journey, starting right here on the planet that holds you, cradling you as you fall asleep, Earth. Earth is the only place you know so well that you can feel it without even thinking about it. You feel it in the weight of your body against the mattress, in the familiar pull of gravity that keeps you safe and grounded while you rest. Of all the planets in the solar system, Earth is the densest, packing more mass into each bit of its volume than any other world. Deep below your feet lies a heavy metallic core wrapped in layers of rock, a compact, layered structure that shapes the planet's gravity, its geology, and its invisible shields against space. This dense core is mostly iron, and in its outer layers, that iron is molten and moving. As it slowly churns, it acts like a giant dynamo, generating Earth's magnetic field. That field extends far out into space, forming a protective bubble called the magnetosphere. It quietly deflects harmful particles from the sun and from deep space, guarding the atmosphere and the surface below, including the room where you're resting now. Without it, the air you breathe could have been stripped away long ago, but instead it stays here, soft and cool, filling your lungs with every gentle breath. Earth is also special because of water. Here, water naturally exists in all three states: solid ice, flowing liquid, and invisible vapor. Ice caps and glaciers, oceans and lakes, clouds and mist all share the same cycle, moving slowly between sea, sky, and land. This balance depends on Earth's distance from the Sun, its air pressure, and its relatively stable climate. As you listen, you can imagine those oceans and clouds as part of a great calm circulation, a planet-sized rhythm that has been flowing, freezing, and evaporating for billions of years, quietly supporting life while you simply breathe and rest. Seasons come and go on Earth because the planet is slightly tilted. Its axis leans at about 23.5 degrees relative to its path around the Sun. And that gentle tilt changes how sunlight falls on each hemisphere throughout the year. When your part of Earth leans toward the Sun, days grow longer and warmer. When it leans away, nights become longer and cooler. You can think of this tilt as Earth's slow, graceful bow to the Sun, creating a repeating pattern of spring, summer, autumn, and winter. Tonight, wherever you are in that cycle, the planet keeps spinning steadily, carrying you softly through space. Under the surface, Earth is not perfectly still. Its outer shell is broken into large plates that slowly shift across the mantle below. This system of plate tectonics creates mountains, deep ocean trenches, and earthquakes, and over long spans of time, it helps regulate the planet's temperature and climate by recycling materials like carbon dioxide. No other planet shows clear active plate tectonics the way Earth does. For your purposes right now, you don't need to picture the details. You can simply imagine the ground as a living, moving skin, very slowly rearranging continents while you lie still on your small patch of it. Up above, in the higher reaches of the atmosphere, Earth's magnetic field and the solar wind meet and dance together. Charged particles spiral along invisible magnetic lines toward the poles, where they collide with atoms in the air. The result is auroras, shimmering curtains of green, red, and violet that ripple across polar skies. You might imagine them as soft lights flickering at the edges of the world, glowing silently while most of the planet sleeps. They are reminders that even in the darkness, there is gentle activity and beauty humming just beyond sight. Sharing this journey with Earth is its large, familiar companion, the Moon. Compared to the size of our planet, the Moon is unusually big, about 1/4 of Earth's diameter. Long ago, a Mars-sized body is believed to have collided with the young Earth, and from the swirling debris, the Moon slowly formed. Since then, it has circled our planet, stabilizing Earth's tilt and influencing its tides. Tonight, whether you can see it or not, the Moon is out there in the sky, moving along its quiet path, keeping its constant, patient watch over the world below. The Moon's gravity gently tugs on Earth's oceans, pulling them into bulges that become high tides. On the side of Earth facing the Moon, water rises slightly, and on the opposite side, it rises as well. As the planet spins, these bulges sweep past coastlines, causing the rhythmic rise and fall of the seas. The Sun plays a role too, shaping especially high or low tides depending on its alignment with the Moon. But the main steady pull is lunar. If you like, you can imagine your own breath moving like a tide, slowly in, slowly out, guided by the same simple pull of gravity that moves entire oceans. The moon is not perfectly fixed in place. Each year, it drifts about 3.8 centimeters farther away from Earth, carried outward by the subtle exchange of energy in the Earth-Moon system. Long ago, it hung larger and brighter in the sky. Far in the future, it will appear smaller, and total solar eclipses will no longer occur the way they do now. But these changes happen over hundreds of millions and billions of years. Timescales so vast that for you, the moon is effectively eternal, a steady companion that will continue to rise and set for every night of your life. Even the moon, which looks so solid and quiet, sometimes trembles. It experiences moonquakes, gentle to moderate quakes caused by tidal stretching, temperature changes, or impacts from space. Without an atmosphere like Earth and without plate tectonics, its surface records these events for a very long time. When astronauts walked on the moon, their footprints sank into fine dust and have remained there, nearly unchanged, for decades. You can think of the moon's surface as a soft, gray memory foam for the solar system, keeping traces of every step, every impact, while it circles Earth in silence. Back on Earth, all these motions, the spinning of the planet, the orbit of the moon, the slow sliding of plates, and the quiet flow of magnetic fields, continue whether you pay attention to them or not. You don't need to hold any of this in your mind. You can let it wash past like a calm, slow-moving river of images. Right now, the only thing you really need to notice is the simplicity of lying here on this dense, protective world under a sky shared with a loyal moon, wrapped in an atmosphere that cradles both your planet and your sleep. Now that Earth and the moon feel a little more familiar and quiet in your mind, you can imagine your awareness slowly expanding outward, not rushing, not straining, just gently widening, as if you're looking up from your pillow and realizing how much more there is above the ceiling and beyond the sky. From our home, the next worlds we'll visit are the nearby rocky planets that share the inner solar system with us: Mercury, Venus, and Mars, along with the broad, mostly empty band of asteroids drifting between Mars and Jupiter. You don't need to remember which is which. You can simply let each world pass by like a calm, slow-moving scene in a dream. Mercury is the closest planet to the Sun, but from Earth it is still a distant, swift little world, moving quickly around our star in a tight, hot orbit. Unlike Earth, Mercury doesn't have a thick atmosphere to hold heat or scatter light. Instead, it is wrapped in a ghostly exosphere, a fragile, almost weightless shell of particles where atoms rarely collide. These atoms are knocked free from the surface by the solar wind and tiny impacts from micrometeoroids, creating a shimmering, invisible envelope made of elements like sodium, potassium, and oxygen. You can imagine Mercury as a small, sunlit stone cloaked in a faint, nearly transparent haze, racing silently through space. Despite the intense heat it receives from the sun, Mercury hides something surprising. At its poles, there are deep craters that never see sunlight, their floors locked in permanent shadow. In these cold, dark pockets, temperatures stay low enough for water ice to survive. Radar reflections from spacecraft have revealed bright patches in these shadowed craters, signs of frozen water preserved for millions of years. Some of this ice may have arrived on comets or been delivered by ancient volcanic activity. It's a gentle reminder that even in harsh places, there can be quiet reservoirs of cold and stillness tucked away from the light. Inside, Mercury is dominated by a huge metallic heart. Its iron core makes up about 80% of the planet's radius, far larger in proportion than the cores of Earth or Venus. The reasons for this oversized core are still uncertain. Perhaps Mercury once had a thicker rocky mantle that was stripped away by a massive impact, or perhaps it formed closer to the Sun where heavier materials naturally gathered. The result is a small world with a thin crust, a giant metal interior, and a weak, delicate magnetic field, a compact survivor from the solar system's restless youth. Even the way Mercury moves around the Sun tells a subtle story. For a long time, astronomers noticed that its closest point to the Sun, its perihelion, slowly shifted more than Newton's laws could explain. This tiny irregularity became one of the first great tests of a new idea, the theory of general relativity. When scientists accounted for the way the Sun's mass bends the fabric of space-time, Mercury's strange orbit suddenly made sense. You can think of this little planet as a quiet piece of evidence circling the Sun again and again, helping confirm how gravity really works, all while you lie here effortlessly under Earth's gentler pull. A bit farther from Earth is Venus, a planet similar in size and mass to our own, but transformed into something entirely different. On the surface, Venus is a furnace world, with temperatures hot enough to melt lead and crushing pressures beneath thick clouds of carbon dioxide. Despite its similarities to Earth's basic structure, Venus lacks a global magnetic field. Its core seems too sluggish or too solid to generate a strong dynamo, leaving the planet exposed to the steady flow of the solar wind. Over time, this may have helped strip away lighter elements from its atmosphere, contributing to the harsh environment that exists there now. Venus also moves in an unusual way. It rotates backward compared to most planets, a slow retrograde spin that makes the Sun appear to rise in the west and set in the east as seen from its surface. A single day on Venus, one full rotation, takes about 243 Earth days, longer than it takes Venus to orbit the Sun. That means a Venusian day is longer than its year. There are many ideas about how this happened. Perhaps a massive collision early in its history, or a long, slow tug from the Sun's gravity on its dense atmosphere. Whatever the cause, you can imagine Venus turning in its own lazy, reversed rhythm, drifting through space in no hurry at all. Unlike Earth, Venus has no moon. Among the rocky planets, only Mercury and Venus orbit alone, without any natural satellites to keep them company. Venus is roughly the same size as Earth, yet where Earth has a large, steady moon to shape tides and stabilize its tilt, Venus circles the Sun without a visible companion in its twilight sky. Some theories suggest that Venus might once had a moon that later drifted back in or was destroyed by a collision. Others suggest that its slow backward rotation just makes stable orbits harder to maintain. However it came to be, Venus is a bright, cloud-wrapped world traveling on its own, bathed in harsh light, but forever distant and quiet from your perspective here in bed. Beyond Venus lies Mars, a smaller, colder planet that has long captured human imagination. Mars is known for its rusty color, a result of iron-rich dust that has oxidized over time, coating its surface in shades of red and brown. Stretching across its equator is Valles Marineris, a canyon system more than 4,000 kilometers long, wide enough to span the continental United States, and in places over 7 kilometers deep. It is a vast scar across the Martian crust, thought to have formed through tectonic stretching, volcanic activity, and erosion. You can picture it as a single, silent wound in a frozen world, carved long ago and now resting in thin, cold air. Mars also hosts Olympus Mons, the tallest volcano in the solar system. Rising nearly 22 kilometers above the surrounding plains, it stands almost 3 times higher than Mount Everest, with a base wide enough to cover an entire large state. On Earth, tectonic plates slowly shift over volcanic hotspots, creating chains of islands and mountains. On Mars, the crust does not move in the same way, so magma could rise and erupt in the same spot over and over, building Olympus Mons into a massive, gently sloping shield volcano. For you, it can be just a calm image, a giant extinct mountain looming under a thin sky, standing watch in the Martian night. The air on Mars is thin and dry, but it is not still. At times, dust storms grow so large they can envelop the entire planet. These storms can last for weeks or even months, turning the sky into a hazy reddish blur and blocking sunlight from reaching the surface. The dust is incredibly fine and can remain suspended in the atmosphere for long periods. Some storms begin as small gusts and then grow as heat, wind, and the shape of the land feed back on one another. In 2018, such a storm brought the Opportunity rover's long mission to an end by covering its solar panels in dust. You can imagine these storms as slow, muffled breaths of the planet itself, rising and fading while you stay still and untouched on your own distant world. Despite its chill, Mars experiences seasons much like Earth. Its axis is tilted by about 25 degrees, close to Earth's 23.5 degrees. So as it orbits the Sun, different hemispheres receive more or less light at different times of the Martian year. This creates cycles of spring, summer, autumn, and winter, changing temperatures, shifting the polar ice caps, and subtly altering air pressure. A Martian year is almost twice as long as an Earth year, so its seasons stretch out slowly. In your mind, you might see them as long, gentle exhalations of a cold desert planet playing out quietly over spans of time that mean little to a single night's sleep. Mars has 2 small moons, Phobos and Deimos. They are irregular, lumpy bodies that look more like asteroids than the round, polished moons you might imagine. Many scientists think they were once part of the asteroid belt and were captured by Mars's gravity long ago. Their low densities and strange orbits support this idea, though other theories suggest they might have formed from debris after a powerful impact. Phobos is slowly spiraling in and will one day break apart or crash into Mars, while Deimos is drifting very gradually away. These tiny moons are like quiet, misshapen stones circling a distant world, reminders of the solar system's chaotic past. Between Mars and the giant planet Jupiter lies a broad region known as the asteroid belt. In movies, it's often shown as a packed maze of tumbling rocks, but in reality, it is mostly empty space. Millions of rocky bodies occupy this region, yet they are separated by vast distances. A spacecraft passing through the belt would almost certainly glide between them without a single collision. The total mass of all the asteroids combined is less than 5% of the Moon's mass, and a few larger bodies like Ceres and Vesta hold much of that material. You can imagine this belt not as a wall of debris, but as a quiet, sparse field of lonely stones drifting in slow, separate paths. Not all asteroids are solid, unbroken rock. Some are rubble piles, loose collections of stones, gravel, and dust held together only by their own weak gravity. These fragile structures can form when larger asteroids collide and break apart, with pieces slowly falling back together over time. Such rubble pile asteroids can contain large empty spaces inside, can spin in odd ways, and may deform under relatively small forces. Space missions visiting these bodies have revealed their delicate, porous nature. You might picture them as floating heaps of ancient rubble, barely cohesive, quietly circling the sun as relics of the solar system's earliest building blocks. Within the asteroid belt, Ceres stands out as something more than a simple rock. It is large enough to be nearly spherical, earning the classification of a dwarf planet. Observations suggest it may contain a subsurface layer of briny water or muddy ice beneath its crust. Bright patches detected on its surface turned out to be salt deposits, possibly left behind by liquid that once welled up and then evaporated. Vesta, another large body in the belt, has a layered structure with a crust, mantle, and metallic core, much like a small, unfinished planet. Together, Ceres and Vesta offer glimpses of worlds that almost became planets but stopped partway through their growth. Even closer to home, some fragments from Mars have found their way to Earth. Powerful impacts on the Martian surface can launch pieces of rock into space, and a few of these fragments eventually cross paths with our planet, falling as meteorites. By studying their chemical makeup and trapped gases, scientists can trace them back to Mars, connecting them to measurements from orbiters and rovers. These meteorites are like small messages from another world, delivered by chance over millions of years. They show that on cosmic timescales, even distant planets can quietly share pieces of themselves. Around Earth's own orbit, there are small bodies called co-orbital asteroids. They do not circle Earth like moons, but they share our general path around the Sun, following gentle, looping trajectories that keep them near our planet without colliding. Some occupy stable positions ahead of or behind Earth, while others drift in long horseshoe-shaped paths. You can think of them as very distant, faint companions, traveling along with us around the Sun, almost invisible, moving at the same grand pace while you move only from waking toward sleep. As your awareness follows this path from Mercury to Venus, from Mars to the asteroid belt and back toward Earth's orbit, you may notice that nothing rushed. Each world is distant, each story is slow, and the space between them is vast and quiet. You do not have to hold the map in your mind or sort them in perfect order. The important thing is simply the feeling of moving gently outward, one small step at a time, while your body remains still, supported by Earth's gravity and by the soft place where you rest. Now the solar system is beginning to feel like a series of gentle rings around your resting place. First Earth and the Moon, then the inner rocky worlds and the quiet belt of asteroids. From here, your attention can drift outward again, this time toward the giants. Huge planets, mostly of gas and ice, each surrounded by its own family of moons and rings. You can imagine them as softly glowing lanterns hanging far out in the dark, with smaller lights circling around them. We will visit Jupiter, Saturn, Uranus, and Neptune, along with some of their most intriguing moons, still keeping every fact intact while letting the mood stay slow, friendly, and sleepy. Jupiter is the largest planet in the solar system, a vast, swirling sphere of gas that could fit more than 1,000 Earths inside it. It does more than just reflect sunlight. It gives off more energy than it receives from the sun. Deep inside, leftover heat from its formation and the slow, continuing contraction of its immense mass generate warmth that rises through its atmosphere. This internal glow drives Jupiter's turbulent weather, its bands of clouds, powerful storms, and ever-shifting patterns. In infrared light, Jupiter shines like a smoldering ember beneath layers of cloud, a not-quite star that almost had enough mass to ignite. Within Jupiter's powerful magnetic field are intense radiation belts, zones filled with fast-moving charged particles. These belts are so strong that an unprotected spacecraft passing through them could be damaged in a matter of hours. The magnetic field itself is the strongest of any planet, stretching far into space to form a giant magnetosphere that dwarfs even the sun's disk when measured in size. This invisible structure captures particles from the solar wind and from volcanic eruptions on nearby moons, channeling them along magnetic lines and generating brilliant auroras near the poles. You can picture this as a huge, unseen shield and light show around a distant world while you live safely beneath Earth's gentler field. One of Jupiter's most famous features is the Great Red Spot, a massive oval-shaped storm in its southern hemisphere. This storm is large enough to swallow multiple Earths and has been observed for at least 300 years. Over centuries, its size has changed, gradually shrinking, but it continues to spin with high winds along its edges, reaching speeds of hundreds of kilometers per hour. Its reddish color may come from complex chemical reactions in the upper atmosphere, where sunlight interacts with compounds stirred up from below. You can imagine this storm as a slow, ancient whirlpool in clouds, turning endlessly while countless nights pass on Earth. Jupiter is surrounded by a remarkable collection of moons, more than 90 that have been identified so far. Among them are the 4 large Galilean moons, Io, Europa, Ganymede, and Callisto, each with its own story. They are like a miniature solar system orbiting Jupiter, bound by its deep gravity well. Some are volcanic, some icy, some possibly hiding oceans beneath their surfaces. Beyond these, a swarm of smaller, irregular moons follow more distant, tilted, or even backward paths, many of them likely captured from elsewhere. Together, they form a complex family circling a giant, all of them distant enough from you that they can be nothing more than calm images drifting through your imagination. Io, the closest of the large moons to Jupiter, is the most volcanic world in the solar system. Its surface is constantly reshaped by eruptions of molten sulfur and rock, painting the ground in shades of yellow, red, and black. Some volcanic plumes rise hundreds of kilometers above the surface, arcing out and falling back in glowing curtains of material. This intense activity is powered by tidal heating. Io is squeezed and stretched by Jupiter's gravity and by the gravitational pulls of neighboring moons. The friction from all this flexing generates heat inside, feeding its restless geology. From far away, you can think of Io as a glowing coal tossed into Jupiter's orbit, always changing, always erupting, while your own world feels quiet and still by comparison. Farther out from Jupiter is Europa, an icy moon that may hide a deep ocean beneath its frozen crust. The surface of Europa is etched with long, dark lines and ridges, signs that the ice shell has cracked, shifted, and refrozen many times. Tidal forces from Jupiter's gravity cause its interior to flex, generating heat that can keep liquid water from freezing solid beneath the ice. Magnetic measurements and chemical clues suggest that this hidden ocean exists, perhaps touching a rocky seafloor below. You might picture Europa as a softly glowing ice sphere, with a dark, liquid ocean sloshing quietly inside, warmed from within and sealed away from the vacuum of space.
The ice on Europa may even move in a way that resembles plate tectonics. Some scientists think that blocks of ice could slide past each other, dive downward, and rise again, similar to how Earth's crustal plates behave, Only here it's frozen water instead of rock. If this is true, it could help cycle nutrients between the surface and ocean, improving the chances for interesting chemistry or even life. For your mind at rest, this can be just a gentle image, a frozen shell on a distant moon, slowly shifting and renewing itself over long stretches of time, all while you simply lie still, feeling your own body slowly soften into the bed. Ganymede, another of Jupiter's large moons, is the biggest natural satellite in the solar system, even larger than the planet Mercury. It has a rocky core, an icy crust, and is thought to hold multiple layers of water oceans, sandwiched between sheets of ice. Remarkably, Ganymede has its own magnetic field, the only moon known to possess one. This field shapes small auroras in its thin atmosphere, tiny glowing bands dancing over a world of ice and rock. You can see Ganymede in your imagination as a vast layered orb, its interior crossed with hidden seas, and its exterior quietly circling Jupiter in the deep, dark cold. Callisto, the fourth major Galilean moon, appears at first glance to be quiet and heavily cratered, with an ancient surface that has not changed much in a very long time. Yet beneath that battered crust, evidence suggests a hidden ocean might also exist, kept liquid by internal heat and insulating ice. Magnetic readings hint at a conductive layer that fits with salty water. If so, Callisto would join Europa and Ganymede as another ocean world in Jupiter's realm. You might picture it as an old, scarred sphere with a secret sea beneath its shell, slowly turning through the darkness, far away and utterly peaceful from your perspective. Beyond Jupiter lies Saturn, famous for its spectacular rings, broad, bright bands encircling the planet. Although they look solid from a distance, the rings are made of countless particles, mostly water ice, ranging from tiny grains to chunks the size of houses. They stretch more than 280,000 kilometers across, yet in many places they are less than 100 meters thick, thinner than tall buildings on Earth. Sunlight glints off these icy particles, making the rings shine against the blackness of space. You can imagine them as a delicate, flat halo around a golden planet, like a luminous disk floating in slow motion. These rings are not permanent. Over time, ring material slowly drifts inward, falling into Saturn's atmosphere in a process called ring rain. Gravity and the planet's magnetic field pull the icy particles down, thinning the rings as millions of years pass. Observations suggest that Saturn's rings may be relatively young in cosmic terms, perhaps less than 100 million years old, and could disappear completely in another few 100 million years. They are beautiful but temporary, a shimmering structure that exists only for a brief moment on the scale of the solar system's age, much like a passing thought that fades as you drift toward sleep. Saturn itself is enormous, yet surprisingly light for its size. Its overall density is lower than that of water, meaning that if you could place Saturn in an unimaginably large bathtub, it would float. The planet is mostly of hydrogen and helium, giving it a gentle, diffuse structure, flattened slightly at the poles and bulged at the equator by its rapid rotation. Storms and bands of clouds move through its thick atmosphere, but from far away, Saturn can feel like a soft pastel globe, with subtle stripes quietly turning beneath its icy rings. Among Saturn's many moons, Titan stands out as a world with familiar shapes made of unfamiliar materials. Titan is the only place in the solar system besides Earth known to have stable liquids on its surface. But its lakes and rivers are not made of water. Instead, they consist of liquid methane and ethane, flowing across a landscape sculpted by cold chemistry. Titan's thick nitrogen-rich atmosphere supports clouds, rain, and even storms, creating a hydrologic-like cycle using hydrocarbons instead of water. You can imagine standing on Titan's surface under a dim orange sky, with lakes and shorelines stretching away in the gloom, alien but strangely calm. Beneath Titan's icy crust, scientists suspect there may be another layer of liquid, a hidden subsurface ocean of water mixed with other substances. If this ocean exists, it lies far below the methane seas, insulated from the frigid surface and warmed by internal heat. Titan becomes in this picture a world of stacked oceans and lakes, each made of different substances, water deep below, hydrocarbons above. For your resting mind, it is enough to see Titan as a layered, misty lantern moon, wrapped in haze and quietly circling Saturn. Enceladus, a much smaller moon of Saturn, holds one of the most dramatic secrets in the outer solar system. Near its south pole, a series of parallel fractures called tiger stripes spew geysers of water vapor and ice grains into space. Tidal forces from Saturn's gravity flex Enceladus's interior, generating heat that keeps an underground ocean liquid beneath the icy shell. The water that erupts into space contains salts, organic compounds, and signs of hydrothermal activity, hinting at warm, energy-rich environments at the ocean's floor. You can imagine Enceladus as a tiny, bright bead of ice, spraying delicate plumes into the darkness, feeding material into one of Saturn's faint outer rings. Farther still is Uranus, an ice giant with a pale blue-green color and one of the strangest orientations of any planet. Most planets spin like tops with their axes tilted slightly, but Uranus is tipped so far over that it effectively rolls around the Sun on its side. Its axial tilt is about 98 degrees, causing its poles to point almost directly at the Sun during parts of its orbit. This leads to extreme seasons, with each pole experiencing decades of sunlight followed by decades of darkness. You might picture Uranus as a sideways spinning marble, slowly turning and circling the Sun, its seasons unfolding on timescales that stretch far beyond a human lifetime. Uranus has a faint system of rings, much darker and less prominent than Saturn's. These rings are made of small, shadowy particles that were only discovered in the late 20th century, when they briefly blocked the light of background stars. They circle the planet in alignment with its tilted axis, so from some angles they appear almost vertical. Uranus also has a collection of icy moons, each following its path through the odd geometry of the planet's tilted magnetic and rotational fields. The whole system feels quiet and understated, a sideways planet with subtle rings and small companions, drifting in a cool, distant region of space. Beyond Uranus lies Neptune, another ice giant, darker blue and more distant. Despite its great distance from the Sun, Neptune is surprisingly active. It radiates about 2.6 times more energy than it receives due to internal heat that powers strong winds and storms in its atmosphere. These winds are the fastest yet observed in the solar system, reaching supersonic speeds as they race around the planet. You can imagine Neptune as a deep blue sphere with bright shifting patches of cloud, where invisible energy from within keeps the atmosphere in constant swirling motion. Neptune was not discovered simply by looking at the sky. Instead, astronomers noticed small, unexplained deviations in the orbit of Uranus and realized that another unseen planet must be tugging on it. Mathematicians calculated where this hidden world should be, and when telescopes were pointed to that spot, Neptune was found. It was the first planet discovered through mathematics before it was clearly seen through glass. This discovery makes Neptune feel, in a way, like a world called forth by careful thought, a distant sphere revealed by the subtle dance of gravity. Neptune is home to at least 14 known moons, but the largest and most unusual is Triton. Triton orbits Neptune in the opposite direction of the planet's rotation, a retrograde orbit that suggests it was captured from the Kuiper belt rather than formed in place. This capture likely disturbed Neptune's original moons and created intense tidal heating within Triton itself. Today, Triton shows signs of cryovolcanism, eruptions of icy material rather than molten rock, and has a thin, shifting atmosphere. You can picture Triton as a cold, pale world, moving backward around its planet, defying the usual patterns, and yet still following its consistent, silent path.
Triton's surface includes strange terrains and patterns that hint at an active geological past. Some regions look like frozen seas, broken and refrozen, while others resemble the rough skin of a melon. Geyser-like plumes may occasionally vent nitrogen gas into space, leaving dark streaks on the bright surface. As Neptune and Triton move together around the Sun, their distant partnership unfolds in slow, long cycles. From where you are, they are nothing more than tiny, faraway actors in a story written on timescales longer than civilizations. A story you are free to let drift out of focus as your eyelids grow heavier. As your attention passes from Jupiter's storms to Saturn's rings, from Uranus's tilted spin to Neptune's winds and Triton's backward orbit, the distances involved grow larger and larger. The giants and their moons form a kind of outer neighborhood around your own world, one that you can visit in imagination
without ever leaving the comfort of your bed. Each world continues its quiet motion, whether you are awake or asleep. And as you listen, you can let the details soften, keeping only a gentle sense of vastness and calm. A feeling that there is plenty of room in the universe for you to relax and drift. As your thoughts drift farther from the giant planets, the solar system begins to feel thinner and quieter. The big, bright worlds are behind you now, and ahead lies a region of small, icy bodies and distant, dim objects. Out here, sunlight is pale and weak, and time seems to stretch out even more. We are moving into the realm of dwarf planets, scattered ice, and the soft outer edges of the sun's influence. Places like Pluto, the Kuiper Belt, the distant Oort cloud, and the long-period comets that occasionally visit the inner system before fading back into the dark. Pluto, once counted among the major planets, now stands as one of the best-known dwarf planets. It orbits far from the sun, in a cold, dim region where nitrogen can freeze solid on the surface. On Pluto's face lies a bright, heart-shaped feature known as Sputnik Planitia. This area is thought to be connected to a vast subsurface ocean beneath the icy crust. Measurements from spacecraft suggest that liquid water might lie below, kept from freezing solid by internal heat and the insulating layers of ice above. You can imagine Pluto as a small, distant world with a hidden, slushy ocean quietly shifting under a frozen, starlit shell. Pluto's orbit is not a perfect circle. It is elongated and tilted, and there are long stretches of time when Pluto is actually closer to the Sun than Neptune is. This last happened between 1979 and 1999, when Pluto briefly took Neptune's place as the 8th planet from the Sun. Even so, there is no danger of the two worlds colliding. Their orbits are locked in a stable resonance. For every 3 trips Neptune makes around the Sun, Pluto completes exactly 2. This gravitational pattern keeps them in a safe celestial dance, their paths weaving but never crossing. In your mind, you can see them as 2 distant dancers moving in slow, repeating steps through the dark. Pluto also has a thin, warm, and knowledgeable astronomy professor with a deep voice. The delivery should be natural, gentle, and calm. Avoid strong exclamations, high-pitched enthusiasm, or dramatic spikes in volume. Keep the tone grounded, steady, and soothing. Speak like a friendly uncle, quietly sharing the mysteries of the universe. The text to narrate is, Pluto also has a thin, fragile atmosphere, made mostly of nitrogen, with traces of methane and carbon monoxide. When Pluto moves closer to the Sun along its orbit, Some of the surface ice warms and sublimates into gas, forming a hazy, layered atmosphere that extends high above the ground. As Pluto travels farther away again, this atmosphere cools and falls back, freezing onto the surface like a global frost. This breathing in and out of its atmosphere happens over the course of its 248-year orbit, a cycle so long that it spans many human lifetimes. You might picture Pluto as a tiny sphere that sighs gently over centuries, exhaling and inhaling an atmosphere that comes and goes. Pluto is not alone in its distant neighborhood. Beyond Neptune stretches a broad ring of icy objects called the Kuiper Belt. It contains countless frozen bodies, some small and irregular, others large and spherical enough to be classified as dwarf planets. Pluto is one of these, but there are others with their own names and stories. Worlds like Eris, Haumea, and Makemake. Together with many more likely candidates, they form a population that may far outnumber the 8 classical planets. You can imagine the Kuiper Belt as a sparse, cold field of icy worlds and fragments scattered along the outer rim of the Sun's domain. Some of these Kuiper Belt objects have remarkably bright reflective surfaces. Haumea, for example, spins fast and has a stretched football-like shape, coated in crystalline water ice that glints in faint sunlight. Eris reflects nearly all the light that reaches it, making it one of the most reflective large bodies in the solar system, brighter than fresh snow when seen up close. These worlds may have been resurfaced by cryovolcanic activity, impacts, or slow chemical changes over time. For your resting mind, they can be thought of as cold mirrors at the edge of the solar system, catching the sun's last pale rays and sending them back into space. The Kuiper Belt, like the inner asteroid belt, contains many smaller objects that never combined into full-sized planets. It is a kind of fossil zone, a frozen archive of the material that built the outer worlds. Some Kuiper Belt objects follow unusual, clustered orbits that have led astronomers to wonder if a much larger, unseen planet may be lurking even farther out, tugging gently on their paths. This hypothetical world, sometimes called Planet 9, has not yet been directly observed. If it exists, it would take thousands of years to make a single orbit around the Sun. You can think of it as a possibility rather than a certainty, a whispered hint that the solar system may still hold large secrets beyond what we've already mapped. Far beyond the Kuiper Belt lies an even more distant hypothetical region called the Oort cloud. It is thought to be a vast spherical shell of icy bodies surrounding the solar system, extending almost a light year from the Sun. Though no Oort cloud objects have been directly seen, many long-period comets,
Those that appear in the inner solar system only once every thousands or millions of years are believed to come from there. These comets travel on elongated, loosely bound orbits. Every so often, the gentle pull of a passing star or the galaxy's tides may nudge one of them inward, sending it on a long, slow journey toward the sun. When a comet falls inward from the Oort cloud or Kuiper belt, the warmth of the sun begins to transform it. Ice on its surface starts to sublimate, releasing gas and dust into space. This material forms a glowing coma around the comet's nucleus and streams out into a tail. The tail does not trail behind the comet like smoke, but always points away from the sun, pushed back by the solar wind and radiation pressure. Often there are two tails, one made of dust, curved and pale, and another made of ionized gas, thin and bluish, stretching in a straight line. You can imagine a comet as a frozen traveler from the edge of the solar system, flaring briefly into beauty as it nears the sun, then fading again into darkness. Long-period comets can spend billions of years drifting quietly in the Oort cloud before being disturbed into motion. When they finally appear in the sky, they are carrying some of the oldest, least changed material in the solar system, primordial mixtures of ice and dust from the time of formation. Their visits are fleeting on human timescales, but they link the inner, familiar worlds to the farthest reaches of the sun's influence. Thinking of them as gentle messengers from afar, you can let the idea of their long, silent journeys soothe you. Nothing about their path is hurried, and their timelines make even the longest human day feel small and manageable. The edge of the solar system is not defined only by gravity. The sun's pull extends far beyond even the Oort cloud. Another way to think about the boundary is through the heliosphere, a vast bubble carved into the interstellar medium by the solar wind. The solar wind is a stream of charged particles flowing outward from the sun in all directions, filling a region of space that includes all the planets and many distant objects. Where this wind finally slows down and meets the thin gas between the stars, it forms a boundary called the heliopause. Beyond that, the particles and magnetic fields of other stars dominate. The heliosphere acts as a giant protective cocoon, deflecting some of the cosmic rays that would otherwise stream into the inner solar system. It is shaped by the balance between the outward push of the solar wind and the pressure of the interstellar medium. As the sun moves through the galaxy, the heliosphere moves with it, drifting through different patches of gas and dust. Right now, the solar system is passing through a region known as the local interstellar cloud,
a diffuse area of gas that is part of a larger structure shaped by ancient supernovae. You can imagine the whole system, the sun, planets, comets, and distant icy bodies sailing together through this gentle galactic fog. Even farther out than Pluto and the Kuiper Belt, the sun still holds on to distant objects with its gravity, and together they all orbit the center of the Milky Way. One full orbit around the galaxy takes on the order of 225 to 250 million years, sometimes called a galactic year. During that time, the solar system passes through different regions of the galaxy, including spiral arms and quieter spaces in between. As this slow journey unfolds, life on Earth rises and changes. Continents drift, species come and go, all while the sun and its family of worlds quietly ride along a vast, almost unimaginable path. While these distant regions mark the outer boundaries of the solar system, there are also small, subtle companions closer to home. Earth shares its orbital neighborhood with co-orbital asteroids that drift in step with our planet, and other planets have similar small bodies traveling with them. Many moons around the giants may have formed from ring systems or from collisions, while others were captured from these distant reservoirs of icy objects. The variety of origins and paths shows that the solar system is not a simple, orderly set of circles, but a dynamic, evolving structure, where orbits shift slowly and bodies trade places over immense spans of time. As your imagination floats out among these remote worlds, icy belts, and hypothetical clouds, you might notice how quiet everything feels. The light is dim, the objects are small and sparse, and the distances are vast. Nothing out here demands urgency or effort from you. These distant regions simply exist, changing slowly, almost imperceptibly. You can allow them to fade gently into the background of your mind, like stars that are still there even when you close your eyes. In the next stretch of this journey, attention can turn back inward toward the sun itself, the glowing heart of the solar system, and to the spacecraft that have carried human instruments to the edge of interstellar space and into the sun's outer atmosphere. Just as your thoughts have moved outward and expanded, they can just as easily drift inward again, following the light back toward the center, growing softer and sleepier with every step. As your thoughts slowly return from the cold, dim edge of the solar system, they can follow a gentle path back toward the light. At the center of everything is the sun, the star that warms your planet, lights your days, and softly touches even the most distant worlds with a faint glow. Around it, invisible fields and winds stretch outward, shaping space in ways you cannot see but constantly feel through the warmth on your skin and the rhythm of life on Earth. From your bed, the sun is far beyond the ceiling and the clouds, yet its presence is as simple and familiar as the quiet glow behind your closed eyes. The sun is mostly made of the two lightest elements, hydrogen and helium. About 70% of its mass is hydrogen, and most of the rest is helium, with only a small fraction made of heavier elements like oxygen, carbon, and nitrogen. Deep in its core, where temperatures exceed 15 million degrees Celsius and pressures are enormous, hydrogen atoms are fused into helium in a process called nuclear fusion. This fusion releases vast amounts of energy, which slowly works its way outward through the sun's layers. By the time this energy reaches the surface and escapes as light, it has taken hundreds of thousands of years to travel from the core to space, but only about 8 minutes more to reach Earth. The visible surface of the sun, called the photosphere, is surprisingly cool compared to the layers above it, about 5,500 degrees Celsius. Above this surface lies the corona, a thin, extended atmosphere that reaches temperatures of over 1,000,000 degrees. This counterintuitive rise in temperature has puzzled scientists for decades. One idea is that magnetic waves from deep inside the sun carry energy upward and deposit it in the corona, heating it from below. Another possibility involves countless tiny, brief eruptions called nanoflares, which release bursts of energy too small to see individually, but powerful in total. You can picture the corona as a faint, hot veil of light surrounding the sun, shimmering with hidden energy. The sun is not quiet inside. It vibrates with pressure waves that ripple through its hot plasma, causing subtle oscillations on its surface. These waves are far below the range of human hearing, but scientists can detect them and use them to study the sun's interior, much like seismic waves are used to understand Earth's inside. This field of study is called helioseismology. By analyzing how the vibrations travel and reflect, researchers can map flows, layers, and rotation inside the sun, revealing structures that would otherwise be invisible. For you, it might be comforting to imagine the sun as a great, gentle instrument, humming with slow, steady notes, its music spreading through space while you drift toward sleep. On the sun's surface, temporary dark patches called sunspots sometimes appear. These are regions where strong magnetic fields reduce the outward flow of heat, making them cooler and darker than their surroundings, even though they are still incredibly hot by everyday standards. Sunspots tend to appear in groups and follow an approximate 11-year cycle, growing more numerous during times of high solar activity and fewer during quieter periods. This pattern is tied to the sun's magnetic field, which gradually becomes tangled and then reorganizes, eventually flipping so that its north and south magnetic poles exchange places. This solar magnetic cycle affects not only sunspots, but also flares and eruptions that ripple outward through the solar system. Solar flares are sudden bursts of energy that occur when magnetic field lines snap and reconnect in the sun's atmosphere. They release intense radiation across many wavelengths, from radio waves to X-rays. Sometimes they are accompanied by coronal mass ejections, in which clouds of charged particles are hurled into space. When these particles reach Earth, they can disturb the upper atmosphere, affect satellites, and in extreme cases cause geomagnetic storms that impact power grids. Most of the time, however, they simply enhance auroras, painting the polar skies with brighter, more frequent lights. You can imagine these events as brief, distant storms on the face of the sun, sending ripples across space that your planet mostly absorbs and softens before they reach you. The sun's constant outflow of charged particles is called the solar wind. This wind streams outward in all directions, carrying with it the sun's magnetic field and forming the heliosphere, a vast bubble that envelops all the planets and many smaller objects. Where the solar wind finally slows and yields to the pressure of the interstellar medium, the heliopause marks the boundary of this bubble. Inside the heliosphere, the sun's influence dominates. Beyond it, the environment is shaped more by the galaxy. You might picture the heliosphere as a softly glowing, protective cocoon drifting through interstellar space, carrying you, the Earth, and every other world along on a slow, patient journey. Within this bubble, two small spacecraft have traveled farther from Earth than any other human-made objects, Voyager 1 and Voyager 2. Launched in the late 1970s, they flew past the giant planets and continued outward, crossing the orbits of Neptune and Pluto and heading into the deep. After more than 40 years, they have reached and passed the heliopause, entering interstellar space while still feeling the sun's distant gravity. Their instruments measure cosmic rays, magnetic fields, and the density of the medium between the stars. Each Voyager carries a golden record, a phonograph disc encoded with sounds and images representing Earth, greetings in many languages, music, and the sounds of nature. These spacecraft are like tiny, quiet messengers, continuing outward long after their creators are gone. Though their power supplies are slowly fading and their instruments are gradually being shut down to conserve energy, the Voyagers still send faint signals that take more than 20 hours to reach Earth. Giant antennas of the Deep Space Network listen for these whispers, decoding them to learn about conditions far beyond any planet. Eventually, the spacecraft will fall silent, but their paths will carry them between the stars for billions of years, long after Earth's surface has changed beyond recognition. You can gently imagine them as two small points of metal and memory gliding through the galaxy in the dark, while you rest in the safety of the sun's warm inner realm. Closer to the sun, another spacecraft has been making daring, repeated dives into the star's outer atmosphere. The Parker Solar Probe, launched in 2018, was designed to fly through the sun's corona, protected by a specially built heat shield. Each orbit brings it closer, and at its fastest, it moves faster than any object humans have made, skimming near the sun at extraordinary speeds. Parker measures particles, fields, and waves in the corona, helping to reveal why it is so hot and how the solar wind is accelerated. You can think of Parker as a small, determined explorer touching the edge of the sun's fiery breath, gathering information while the star continues to shine steadily, unaware of the tiny visitor in its vast environment. Beyond the sun and its missions, there are many other stars in the sky, each with their own planets, winds, and subtle boundaries. But tonight, those distant systems can remain just background glimmers, soft points of light you do not need to explore. For now, it is enough to know that your own star has its cycles, storms, and quiet phases, and that Earth's magnetic field and atmosphere filter and soften much of what happens there, making life possible and comfortable on the surface. The same sun that powers fierce flares and energetic winds is also the gentle source of morning light, warm afternoons, and the glow that slowly fades toward night. As this journey through the solar system begins to close, you might remember that everything you have visited in your imagination, the dense earth beneath you, the moon, the inner rocky planets, the asteroid belt, the giant worlds and their moons, the distant dwarf planets and icy clouds, the sun and its winds, continues to move in quiet, predictable patterns, whether you are awake or asleep. Planetary rings slowly change. Moons wander inward or outward. Atmospheres leak into space grain by grain. Yet all of this unfolds on time scales so long and gentle that one human night, one moment of rest, is just a tiny, peaceful pause within them. You do not need to keep track of the order of worlds or the names of moons. You do not have to hold on to the numbers or the distances or the temperatures. You can allow all of it to soften into the simple, comforting idea that you live in a spacious, intricate home. A solar system where gravity guides everything into orbits and cycles, and where there is room for calm as well as motion. As these images fade, what remains is the feeling of being small but safe, resting on a warm planet under a protective sky with a quiet star watching over you.